Hello, this is Josiah Winslow, recording for his Programming in Java course at METC for instructor Mark Cribb. Now this is my assignment 3. We've been asked to read chapters 3 and 4 in our textbooks and do some programming challenges from each of the chapters. I'm going to show you how I did those here. And before I get started, I want to say that I updated my installation of NetBeans. I used to have NetBeans version 8, which, for context, that was current back in 2014. So I had some updating to do. My version is 12.4 now, which is the latest. And classmates, if you are wondering how I got this dark theme and you want to get a dark theme of your own on NetBeans, I went to Tools, Options, Appearance, Look and Feel, and there's a list of themes you can choose. I chose Flat Left Dark because I like the look of it the best. And then you can press OK. And then you'll have to restart NetBeans for that to take effect. So my program allows you to choose between the two different chapters and choose between a few different challenges for each chapter, and then executes that challenge. So I have a chapter class, it's an abstract class, and it's very simple. It has a name, some challenge indices, and some challenge classes, a simple constructor, and some simple getters. And chapter 3 and chapter 4 are extensions of chapter, which are basically just the constructor called with these arguments, decision structures. We're doing challenges 4, 17, and 18 from chapter 3. And chapter 4 is loops and files. We're doing challenges 8, 16, and 22. And challenge is its own abstract class with name and execute function, which is going to be overwritten by each of the extending classes. And it's got a simple constructor, simple getter. And anyways, this selector for the different chapters and different challenges works very simply. We've got some chapter indices 3 and 4, and some chapter classes, chapter 3 and chapter 4. We loop through them, output their numbers and names, and then we ask them to enter a chapter, and we're going to ask them until it's either 3 or 4 with this function input choice int. I implemented this last time for my assignment 2 video, so if I can, I'll link that either up in the top corner, I believe it's this one, or down in the description. But input choice int basically loops through asking until we get some choice in that list. And then we get the index of that choice in chapter indices, and then we get the index of that into the chapter classes to get the proper chapter class. And it's the same deal with the challenges. We get the right challenge, and then we execute that challenge with the execute function. And that is almost everything in this main file right here. But here we have input choice int, which I've implemented before. And I also implemented an input choice string, which is very similar, and an input choice char. I don't use input choice string actually in this one, though I think I will in the future. I use input choice char a lot for yes and no selections. And also for this, I made, instead of a list of characters, I have a string, because I can use the contains function with that to check if the string contains a certain character. And I have a boolean for case sensitivity, that if the choice is not case sensitive, it converts both the choices string and the choice character to lowercase before comparing them and checking for membership. And yeah, that's pretty much everything right here. So let's look at how I implemented each of the challenges. So, Chapter 3 Challenge 4, Test Scores and Grade. We are supposed to ask for 3 test scores and compute their average and compute the letter grade associated with them according to this chart. So right here I have an array of letter grades, A, B, C, D, and F. Each of them are chars. And I have some minimum scores, which are the minimum scores needed to require for minimum scores required for each of the corresponding letter grades. So if it's at least 90, then it's an A. Otherwise, if it's at least 80, then it's a B. Otherwise, if it's at least 70, then it's a C. Otherwise, if it's at least 60, then it's a D. Otherwise, if it's at least 0, then it's an F. So this is very simple. Ask for each of the scores, add them up, divide by 3.0, and here's where I get the letter grade for the average score. So I initialize a character to a question mark just in case. And for each of the entries in these parallel arrays, if the average score we calculated is greater than or equal to the current minimum score, then the letter grade is the current letter grade. And then we break out of the loop. And this keeps going until it finds something or it gives up. And then we output the average score and letter grade. So let's test that out, shall we? Taking longer to build than I was expecting. But here we go. Chapter 3, Challenge 4. Enter score 1. Let's say it's a really good score. Let's say it's 100. Enter score 2. Let's say it's really bad, like a 67. And score 3. Let's say it's 90. It's on the higher end. So the average score is 85.6 repeating, and the letter grade is a B because it's not quite 90 for an A, but it's over 80, and so it hits the B. So now let's move on to challenge 17 in the same chapter, Wi-Fi diagnostic tree. Wi-Fi diagnostic tree is basically we repeat different troubleshooting steps for fixing a broken router and modem, and we keep going until the person says, yes, this fixed our problem, or the program gives up and just tells us give a new router. So I have troubleshooting steps right here, TS steps, and they are strings corresponding to each troubleshooting step. And I have the last step in its own variable outside of this for a reason why that you'll see in a second. So Boolean problem fixed is going to be false initially because our problem is not fixed. And here's how we loop through the troubleshooting steps. This looks a little funky, but basically it's looping through every entry in the TS steps array and then putting those in a variable called TS every time it iterates through the loop. This is a very short way of implementing a loop through an array without having to use an index, and it's much less typing than using an index as well. So for each step, we print out the troubleshooting step, we use input choice char, the function we had earlier, to get a character from the user, Y or N, and that'll be an answer to did that fix the problem. And if this character is Y, then yes, this was fixed and problem fixed is true, and we break out of the loop. Otherwise it keeps going. Now at the end of this loop, either the problem is going to be fixed or it won't be. And if it is not fixed, then we output the last step, which is why I have this separate from the others, because it doesn't really fit into the loop thing. Otherwise, if the problem is fixed, we don't output this. So let's very quickly test this out. Reboot the computer and try to connect. Did that fix the problem? No. Reboot the router and try to connect. Did that fix the problem? Yes, it did. And then it ends the program. And let's test out what happens if we keep saying no. So did that fix the problem? No, nothing's gonna fix the problem. Get a new router. So that works. And let's move on to challenge 18. So the challenge is Restaurant Selector. We have a choice of a few different restaurants. Some of them serve vegetarian options, some don't. Some serve vegan options, some don't. Some serve gluten-free options, some don't. And if anyone in your party is a vegetarian, vegan, or gluten-free, then we have to return only those restaurants where the dietary restrictions of your party can be honored. So here I have a list of restaurants, which restaurant is a new class that I implemented. It's very simple. It's got a string for the name, a boolean for each of the dietary restrictions that it can honor, a simple constructor, simple getters, and each of these is an instantiation of the restaurant class. For Joe's Gourmet Burgers, Main Street Pizza Company, Joe's Gourmet Burgers can't fulfill any of these requests. Main Street Pizza Company can fill the vegetarian and gluten-free requests, etc., etc. So for the challenge, we get an input choice character for is anyone in your party a vegetarian, Y or N? And then if it's equal to Y, then this boolean is going to be true. Otherwise, if it's going to be equal to N, then it's going to be false. So we ask that 3 times, one for each of the 3 questions. And then we say, here are your restaurant choices. We loop through all the restaurants, and if this big conditional is true, which means the restaurant can fulfill our dietary restrictions, then we print the name. So this is a chaining of a bunch of different statements. So this statement is going to be true if either the party is not vegetarian, or if the restaurant could fulfill that vegetarian requirement anyways. And it's going to be this for vegetarian and vegan and gluten-free. So with that, let's test this out. And we should see all 5 restaurants if we answer no to all of these questions, because none of the restaurants have to do any special dietary restriction fulfillments. And see, we have 5 restaurants there. However, if on the other hand, someone in our party is vegetarian and another person is gluten-free, these are the only restaurants that will be able to fulfill both of those requests. And the only restaurants that are able to fulfill every request is Corner Cafe and the Chef's Kitchen. See, I like these restaurants because I actually am a vegetarian, but with that out of the way, this works. And let's go on to Chapter 4 now. So we're at Chapter 4, Challenge 8, Average Rainfall. We have to ask for a number of years, and then for every month in that year, we have to ask for every month in every year, we have to ask for the amount of rainfall that month, and then we're going to keep a running tally of the total rainfall, and we're going to output the number of months, the total rainfall, and the average rainfall per month. Also, we're going to do some input validation. So we have a string array of month names that I just put all the month names in. This is 12 strings long, and that is how we're going to loop through the months. So ask for a number of years. We're going to put it in a do while true loop, which executes at least once because of the do, and executes while true is true, so forever, until it's broken out of. So years is equal to whatever we input. If years is less than 1, this is one part of our input validation. If years is less than 1, then we say enter a positive number of years, and we keep looping until they enter a positive number of years. And if they do, we break out of the loop. Same thing here. total rainfall is equal to 0, and then we're going to loop over each year like this, and we're going to loop over each month like this in the funky way we saw before. Then another do while true loop, enter the current rainfall. If our rainfall is negative, that can't happen unless, I suppose, the water gets sucked out of the ground or something. And then we have to say enter a non-negative rainfall amount. Otherwise, if we have a proper amount, then we break out of the loop and add that current rainfall to the total rainfall. And then once we're out of both of those loops, we calculate the number of months, years times months names dot length, so it's years times 12 basically. We output the number of months, the total rainfall in inches, and the average rainfall in inches per month. And for that we have to divide total rainfall by number of months, and it's important that number of months is a double here instead of an int, because otherwise it'll do an integer division. And we want those extra digits of precision. So, Chapter 4, Challenge 8. I'm not going to go crazy. I'm just going to do this for 1 year, but this works for multiple years as well. So we're going to enter in all these different amounts. And then once we're done, it gives us the number of months, total rainfall, 31.73 inches, and the average rainfall, 2.64 something inches a month. So that's good. Now we move on to budget analysis, Chapter 4, Challenge 16. So we have to ask the amount that the user's budgeted for a month, and then loop for asking a whole bunch of different expenses during the month, and we have to keep a running tally of those, and when the loop is done, it'll display the amount that we're over or under the budget. So ask for the budget, initialize expenses to 0, and then a do while true loop until we enter in a 0. That is the scheme that I chose for the loop. If current expenses equal 0, then break, and we're at our final item. Otherwise, keep looping and add the current expense to the total expenses. And finally, if budget is equal to expenses, then we are exactly on budget and we're not over or under at all. Otherwise, we are this amount over or under the budget. And math.abs is a function that takes the absolute value of something, so it turns it positive if it's negative, otherwise it is staying positive. And we're getting the absolute value of the budget minus the expenses. So it's going to be like some amount, and then it's going to be either under or over the budget. Now this is a funky syntax called a ternary operation. A ternary operator, excuse me. If expenses is less than budget, then under. Else, over. It saves a bit of typing over an if-else statement, and it's a very useful shorthand. So with that, let's see if it works. So enter budget for the month. Let's say we have a $200 budget. We spend $150 on groceries. We spend $34 on the newest video game. And we spend $1.99 on a sandwich. And luckily for us, we are $14.01 under budget. And if we run this again, let's just do an example for spending exactly as much as our budget. So let's say we have $10 a budget, and we spend $10. Look at us. We're exactly on budget. We're not over or under at all. Okay, and this is the final challenge, and this was my favorite to do. A slot machine simulation. So, we are asked to input a certain amount of money, and that will be put into a slot machine, and then you push a lever or pull a lever or push a button, and then the slot machine displays 3 different symbols out of this list of symbols: cherries, oranges, plums, bells, melons, and bars. And if none of them match, we win $0. If 2 of them match, we win twice the money that we entered. And if we match 3 of them, we win thrice the amount of money we entered. And then we keep going and playing again and again until the user gets tired, or they leave the casino. And we also have some extra credit for this, courtesy of Mr. Crib. Assign the player $100 to start the game, so we actually have stakes now, and we ensure the player does not bet more than they have, then decrement the bet amount from their total, run the game, add any winnings to that total, and then start again with a new total. So we're basically going until we run out of money. And we only have $100 to start with. So these are the different symbols, which I named fruits because most of these are fruits, except for the bells and bars, I guess. Number of symbols is 3. I made this work with more than 3, by the way. And starting money, 100. So we're using the random class to generate random numbers for each of these symbols. We initialize the total amount of money you've spent in the machine to 0, and the net money is equal to 100. And so we keep running this loop where it outputs the money so far, and we ask for money while also validating that we don't do an amount that's 0 or less, and we don't do more than we have. Then add that to the total spent and subtract that from the money we have. Now this is the loop where we generate the random symbols, and while we generate the random symbols, I also count how many of each symbol there is, and whatever the maximum count for a symbol is, that's how many of the symbols that repeat. So here I have a string list of symbols and an int array of symbol counts that is as big as fruits.length. So we have 1 of these symbol counts for each fruit. Now this is already initialized to 0 because the default value of an int is 0, so says this section of the specs. But if we wanted to, we could uncomment this line, and we could still fill symbol counts with 0 if we wanted to. And we also have a max count, which keeps track of the maximum number in this symbol counts array as we go along. So we loop through each of the symbols, we generate the symbol with ran.nextInt fruits.length, which is going to generate a number from 0 to 5 because fruits.length is 6, and this is how nextInt works. Then we add that symbol, fruits s, the sth number in the fruits array, if we generate a number, and of course we also use string.format to put brackets around that. Then we add 1 to the count of that symbol in symbol counts, and if symbol counts is greater than our current max count, then we update our max count to that symbol count. So we do this 3 times, or however many times num symbols is. Then we print the symbols by joining them together with a space with string.join. And then we decide the winnings. We have a double for winnings. And by the way, I wish this syntax actually doubled your winnings. That'd be kind of awesome. And then we have a switch statement. So in the case that max count is 1, 1 means that there is so there is going to be at least 1 of every symbol that is in that array, because that's kind of how membership in an array works. And so if max count is 1, that means that for every one of the symbols, that are in the array, there's only one of them, and there's no repeats. So no symbols matched. That means winnings is 0, and we've matched no symbols. Otherwise, if max count is 2, then we've matched 2 symbols. If max count is 3, we've matched 3 symbols. And if max count is 1 billion, we've matched 1 billion symbols. We're not going to get 1 billion with 3, but in any case, we're going to take that max count times the money. So this will be 2 times the money if it's 2, 3 times the money if it's 3, just like the requirements say. And it'll say we've matched max count number of symbols. And then once we're out of that switch statement, it tells us how much we've won, adds it to the money we've won. And here we check if we have no money or less. I could just do equals, but I want to be safe. So if net money is less than or equal to 0, then we've lost all our money and we have to break out of the loop. Otherwise, it says you now have this amount of money. Then we use input choice char to ask, do you want to play again? And while that character is not no, or I guess I could have done while it equals yes, then we keep looping that slot machine game. And then at the end, we output the total spent and the total amount of money you're left with. So let's play this for a little while. So your money so far. How much money do you want to enter? Let's input a modest $10. And, we matched no symbols. Do you want to play again? Sure. Let's bet another $10. Oh, look at that. We've made back the money we lost. So we matched bars and bars. That's 2 symbols. So we have exactly as much money as we started with. I'm feeling lucky. Let's bet $50. Oh, and look at that. Cherries and cherries. We've matched 2 symbols. So we have 150. Let's play again. Double or nothing. Nothing. So melons, bells, cherries. There's no matches. And we've lost all of our money. We spent $220 at the machine, and we have nothing to show for it. So that is a pretty somber note to end the video on, but that is our last programming challenge, and we are done. So, students, classmates, if you have any questions about this assignment, or if you need help, or if you want to help somebody else with this assignment, you know where to do that in the discussion board. I would encourage anybody who wants help or who can help to go into the discussion board and talk about it. And with that out of the way, Mr. Crib, I hope you like it, and I hope you give me a good grade on this assignment. Take care.